Sir Isaac Newton was born in Lincolnshire, England on Christmas Day 1642. He is one of the most recognized scientists in history. Despite a traumatic childhood, he became a key figure in the scientific revolution in the 17th century. One of his most significant contributions are the laws of motion. We see Newton's laws of motion in our lives every day and not notice it. That's why I think that this is one of the most important topics. Before we can learn Newton's second law, it's important to know a little side concept called acceleration. Acceleration is the rate of change of velocity in an object. The unit of measurement for acceleration is meters per second squared. The formula for acceleration is A is equal to final velocity minus initial velocity divided by final time divided by initial time. The second law of motion. This law states that when a net force acts on an object, the object accelerates in the direction of the net force. The acceleration is directly proportional to the net force and inversely proportional to the mass of the object. In numerical form, it can be expressed as F equals ma, F being the force, m being the mass, and a being the acceleration. A car that weighs 500 kilograms starts from rest, and after 10 seconds, the car has a speed of 300 km/h. What is the force of the car? Sample question 1. We can tell from the question that the mass of the car is 500 kilograms. The initial velocity is always 0 when an object starts from rest, and the final velocity, as mentioned, is 300 kilometers per hour. As I mentioned before, we have to convert kilometers per hour into meters per second when we substitute it into the equation. This gives us 83.33 meters per second. Time taken for the car to reach from rest to 300 kilometers per hour is 10 seconds, so t is equal to 10. The formula, as mentioned before, is v minus u by t is equal to a. Another formula we're going to use is F is equal to ma. When you substitute the values into the formula, we get A is equal to 83.33 by 10, which makes A, acceleration, 8.33 meters per second squared. Please excuse me as I've written meters per second and not meters per second squared. Now, as we have the acceleration, we can calculate the force of the car. Please excuse me as I've written 500,000 instead of 500 for the mass, while substituting into the formula F is equal to ma. The force of the car is 500 multiplied by 8.33. The SI unit of force is newtons, so the car's force is 4166.65 newtons. Mr. Warner has to choose between two cricket bats. The first bat weighs 3.4 kgs and the second weighs 2.8. The first one can be swung at a final velocity of 80 kilometers an hour from a state of rest in a second, and the second one can be swung at 90 kilometers an hour from a state of rest in 1 second. Which one has a higher force? Sample question 2. From this question, we can tell that the mass of the first cricket bat is 3.4 kgs. The initial velocity of this bat is 0 meters per second as it starts from rest. The final velocity is mentioned to be 80 kilometers per hour, but since we need our answer in meters per second, it's 22 meters per second. The time taken to reach this acceleration is 1 second. The formulas we're going to use is F is equal to ma and v minus u by t is equal to a. When we substitute the values into the formula, we get the acceleration as 22.2 divided by 1, which is 22.2. So as we get the acceleration as 22.2, we can now find the force, which is 22.2 multiplied by 34. The total force is 75.548 newtons. The second bat has a weight of 3 kilograms and an initial speed of 0 as it starts from rest. Its final speed is 90 kilometers per hour, which is 25 meters per second. The time it takes to reach this acceleration is also 1. When you substitute this into the formula, we get the acceleration to be 25 and the force to be 25 multiplied by 3, which is 75. The question asks us which bat has a higher force. So the first bat had a force of 75.548 Newton, and the second bat had a force of exactly 75 newtons. So we can say that the first bat had a higher force.